Okay, so question number 10. You want to express these matrices as the sum of a symmetric and a skew-symmetric matrix. And we said that basically if you have some matrix A, for example, A plus A prime, actually that's not the right way of writing it. Let's say that you have some square matrix A, and A plus A prime is always a symmetric matrix, and A minus A prime is also a skew-symmetric matrix. And we proved that basically based on the same logic, you can say that one half of or any other scalar multiplied by the matrix, for that matter, but specifically 1/2 of A plus A prime is also not whole prime, but 1/2 of A plus A prime is also a symmetric matrix, and 1/2 of A minus A prime is also a skew-symmetric matrix. Now as it turns out, we can write this matrix A as basically 1/2 of A plus A prime plus 1/2 of A minus A prime. And since this is a symmetric matrix, this is a skew-symmetric matrix, then you would have written A as the sum of a symmetric and a skew-symmetric matrix. And it's important here to note that basically if you expand this part, the first part, the right hand side of this, you'll get 1/2 A plus 1/2 A prime plus 1/2 A minus 1/2 A prime, and these two will cancel out, and then you will have basically 1/2 A plus 1/2 A, which is equal to A, which means that A is equal to A, right? So now what I need to do is that I need to take my matrix A and calculate A plus A prime, and calculate 1/2 of A plus A prime, and then by the same logic calculate 1/2 of A minus A prime, and then I would have written my matrix A as the sum of a symmetric and a skew-symmetric matrix. So now if I have, for example, A as 3, 5, 1, -1, then in this case A prime would be equal to 3, 5, 1 and -1, and therefore 1/2 of basically A plus A prime would be equal to 1/2 of the sum of these two matrices, which is 6, 6, 6 and -2, and 1/2 of A minus A prime would be basically 1/2 of A minus A prime. 3 minus 3 is equal to 0, 5 minus 1 is equal to 4, 1 minus 5 is equal to -4, and -1 plus 1 is equal to 0. And now you can write A is equal to, I have to multiply here, so 6 divided by 2 is equal to 3, 3, 3, and -1. And this matrix would be 0, 2, -2, and 0. And now I can write basically, A is equal to 1/2 of A plus A prime plus 1/2 of A minus A prime, and therefore I can say that 3, 5, 1, -1, which is A, is equal to this matrix plus this matrix, which is 3, 3, 3, -1 plus 0, 2, -2, 0. And in order to verify, if I do 3 plus 0 is equal to 3, 3 plus 2 is equal to 5, 3 plus -2 is equal to 1, and -1 plus 0 is equal to -1, which is true. So that was part 1 of this question. Part 2 of this question, let's say that your A is equal to, for example, 6, -2, +2, -2, +3, -1, 2, -1, and for example 3. And so again, I have to do the same thing, meaning that I have to write A as basically I have to write A as 1/2 of A plus A prime plus 1/2 of A minus A prime. So now what is A prime here? A prime is equal to basically 6, -2, 2, 6, -2, 2, -2, 3, -1, and 2, -1, 3. Now, we have 1/2 of A plus A prime, which is equal to 1/2 of A plus A prime is the sum of these two matrices. 6 plus 6 is equal to 12, -4, +4, -4, +6, -2, 4, -2, and 6, which is equal to 12 halves is equal to 6, -2, -2, 3, -1, 2, -1, and 3. And 1/2 of A minus A prime, is equal to basically 1/2 of this matrix minus this matrix. 6 minus 6 is equal to 0. -2 plus 2 is equal to 0. Actually, -2 minus -2 is, well, it is 0, of course. 2 minus 2 is equal to 0. -2, -2 is equal to 0. 3, 3 is 0. Seems that they are actually the same matrices, so you get all zeros here. And so that is the same thing as 0, 0, 0, 0, 0, 0, 0, 0, 0. And if you add this matrix to this matrix, you should get A, which is actually true because this is 6, -2, 2, -2, 3, -1, and 2, -1, 3, which is the same thing as A. So basically the whole thing is fits together, right? Now, I'm not, there is 2 more exercises here that I leave to you because I mean, there is no point in doing them anymore. And question number 11, you want to choose the correct answer in exercise 11 and 12. So we have, if A, B are symmetric matrices, of the same order, then AB minus BA is, basically skew symmetric. A is skew symmetric. Then B is basically symmetric. B is symmetric. C is 0 matrix. And D is identity matrix. Identity matrix. Now, okay, so Well, I did try to solve this problem, but I actually didn't get the solution. And then I took a look at the solution, and it's actually been solved in an interesting way. So basically, so the question is, if A and B are basically symmetric matrices of the same order, then AB minus BA is, what sort of matrix is that? So if I write AB minus BA, and take the transpose of that, that's going to be equal to basically AB whole prime minus BA whole prime, because basically x minus y whole prime is equal to x prime minus y prime, right? Now I'm doing this because we have basically two definitions here. So in a symmetric matrix, we know that A is equal to A prime, right? That is a symmetric matrix. In a skew-symmetric matrix, we know that A prime is equal to negative A. Now we need to know if you take the transpose of this matrix, what is it going to be equal to, right? So now you can write AB whole prime minus BA whole prime. You can write it as basically B prime times A prime. B prime times A prime minus A prime times B prime. A prime times B prime, because, and the reason is that, of course, as you know, xy whole prime is equal to y prime times x prime, right? Then you can write this as now, here we said that AB are symmetric matrices, meaning that since AB are symmetric matrices, you can say that A prime is equal to A, and B prime is equal to B, right? So here, instead of B prime, I can write B, and instead of A prime, I can write A, which means that here I can write BA minus AB, right? And because basically A and B are symmetric. Now this is BA minus AB, and if I take the negative of this, negative of AB minus BA, so that means that basically AB minus BA whole prime is the same thing as negative of AB minus BA. And therefore, based on the definition that we had, AB minus BA is skew symmetric. And therefore, the option A is correct. Okay, that was an interesting question. Okay, so the next question, question number 12. Question number 12, we have, if A is equal to this matrix as cos alpha, negative sine alpha, and sine alpha and cos alpha, and a plus a prime is equal to the identity matrix, then the value of alpha is A pi by 6, B pi by 3, C pi, and D 3 pi by 2. Okay, so the identity matrix, first of all, if I calculate if I write basically a plus a prime is equal to I, that means that, and a prime would be equal to basically cos alpha negative sine alpha, and sine alpha cos alpha, and then a plus a prime would be this matrix as cos alpha plus cos alpha 2 times cos alpha, negative sine alpha plus sine alpha would be 0, sine alpha minus sine alpha is equal to 0, and cos alpha plus that would be 2 times cos alpha is equal to the identity matrix, which is 1, 0, 0, 1. Now 0 is equal to 0, 0 is equal to 0, and 2 times cos alpha is equal to 1, and here 2 times cos alpha is equal to 1. That means that cos alpha is equal to 1 by 2, which means that alpha is equal to alpha must be basically a 60-degree angle, of course, because alpha would be equal to the cos inverse of 1 by 2, and that would be a 60-degree angle, which is pi by 3. So then the answer is, of course, choice B. Choice B is the correct answer, right? Okay, so that was basically that was question number 12. So this is the end of these exercises. In the next videos, we will talk about elementary operations or transformation on matrices. We have and then we have something called invertible matrices, a couple of theorems, inverse of a matrix by elementary operations, and that's about it, I suppose. There is nothing left here. I mean, concept-wise, we are done here. So I'll see you in the next video with basically elementary operations or transformations on a matrix. Thank you.